Hi, and welcome to Komsky Corner. Today we're going to continue talking about defining, creating, and refining algorithms, focusing on common errors and trace tables. This video is specifically for the new OCR GCSE Computer Science course. However, it is applicable for most exam boards. Let's have a look at some common errors that are made when writing algorithms, whether that be in pseudocode, as a flowchart, or in actual program code. There are two main types of errors. The first type of error is called a syntax error. Syntax errors are errors in the grammar of a program that break the rules of the programming language. Syntax errors in your program will stop the program from running. Examples of syntax errors include things like misspelled words, missing brackets, etc. The second type of error that we could have in our program are logic errors. Logic errors are faults in the logic or structure of the program, which could be caused by accidentally programming the wrong thing, or having your code make the wrong decision. They result in an unexpected result, but the program will still run. Logical errors are generally harder to spot, and examples of them include incorrectly using logical operations, accidentally creating an infinite loop, etc. Let's look at an example of a program with a syntax and logical error in the next slide. So on the screen there is a piece of code that outputs the next 5 numbers after the one entered by the user. There is one syntax error and one logical error in this code. Pause the video here and see if you can spot them. So the first thing we are looking for in this code is a syntax error, so something that breaks the rules of the programming language, like a misspelt word or missing punctuation. In this code, we can see that we have a syntax error in the last line of the code, as the keyword print has been misspelt, which will stop the code from being able to run. For the logical error, we are looking for something that causes the program to run incorrectly, or not as we intended. If we look back at the comment at the top of the code to see what the code should be doing, we can see that the code is supposed to output the next 5 numbers after the one that is inputted by the user. If we step through the code line by line, we can try and spot if this happens, and if not, where the error is. So in the first line, the program is simply asking the user to input a number, and is storing it in a variable called number, which is fine. In the second line, we have a for loop, which is looping through the program 5 times, which makes sense as we want to output 5 numbers. In the next line, we are subtracting 1 from the inputted number before printing it out in the final line. Well, that's going to be a problem, right? Because that means that the program is going to output the 5 previous numbers from the one inputted, not the next 5 numbers like we want. Therefore, our logic error is in line 3, where the number inputted is being decremented by 1 for each of the 5 iterations of the loop. So the previous 5 numbers are being outputted, as opposed to the next 5 numbers like intended. Instead, we should be incrementing our loop by 1 each time. Sometimes, as well as stepping through the program line by line, it can be helpful to assign a number to the input and see what happens to it, comparing it to what should happen as the expected output. For example, for this program, we could take the number inputted to be 10. The expected output would be 11, 12, 13, 14, 15. But as we trace through this code, we can see that the actual output would be 9, 8, 7, 6, 5. This is called tracing through the algorithm, and we can use something called trace tables to do this. We follow the steps of an algorithm, keeping track of the inputs, variables, and outputs as we do so. In the trace table, we have columns for each of the different variables, and a column for the output. Let's have a look at a proper example. In this example, we have a program that is using a condition-controlled loop, and we have 2 variables x and y. So our trace table is going to look like this. one column for x, one column for y, and one column for the output. Initially, in our program, x has been set to 15, and y has been set to 0, so this will make up the first row of our trace table. Next, we enter our loop as our value of x is 15, which is bigger than 0, so the condition to enter our loop is satisfied. In the loop, we increment our value of y by 1, so y becomes 1, and subtract this value of y from x, so x becomes 14. X is 14, so still bigger than 0, so we repeat this process. We add 1 to y, so y becomes 2, and then subtract this 2 from x, so x becomes 14. We repeat this until we get to x is 0 and y is 5, because at this point x is not bigger than 0, so we exit our loop and print y. So as y is 5, we put 5 in our output column. As you can see, we have set up our trace table so that each row of the table is a new iteration or step. Tracing through an algorithm using a trace table like this helps us understand the algorithm as well as spot errors, which is especially useful if the algorithm is quite large or complex. As a challenge, have a go at tracing through the algorithm on the previous slide, where the input is 15. Here is what your truth table should look like. In this video, we have finished looking at defining, creating, and refining algorithms, including syntax and logic errors, and using trace tables to trace through an algorithm. If you have enjoyed this video, please be sure to give it a big thumbs up and subscribe to my channel for more. See you next time. Bye!